Start with our star. Several active regions were responsible for the flaring we saw over the last day. Biggest flash, bottom left, is from the X-class flare, but we can see several different impulsive events. Luckily, there were only smaller CMEs produced from the flaring, and none of them were aimed our way. We currently have no coronal holes on the Earth-facing side. In the higher energy view, we can better locate all those flaring events. Big one, bottom left again, but we also had flaring from the northern incoming group and from the southern sunspots crossing through towards the far side. This higher level of activity sustained for days is the hallmark of entering sunspot maximum, where we are now. We can likely expect more flaring from these active regions. There are quite a few. The south remains a train of sunspots, and up north we see the emergence of that new grouping now as well. Eyes on all of it. Couple bits of eye candy here, starting with the Tarantula Nebula infrared from James Webb Space Telescope, combining with X-rays from Chandra. This new composite image is quite amazing and represents the most detailed all-light composite of the nebula to date. We also have a good 9-year progression of the Namibian sand dunes, 9 years of satellite images stitched together here to show the movement of these features over time. Today's top story is dishonesty coming from the UN Climate Group. Shocker. They are saying that reduction in certain chemicals is leading to a recovery of the ozone, and this is an especially devious misdirection on their part. We just ended 2022, which did have a smaller ozone hole, but 2021 had a pretty large one. This was also the case in 2020, while back in 2019 it was a little smaller. There is a large amount of annual fluctuation. But after a 2022 smaller ozone hole, they now want to claim that we're on the road to recovery. That's not only inappropriate based on 1 year following 2 straight years of larger ozone holes, but their rationale for why it happened is nonsense. Folks, solar particles destroy ozone as much or more than the chemicals they discuss, and solar UV light increases ozone through photoionization processes. As shown here in the solar radio flux, which is a good proxy for solar activity, 2022 was the year we went from the smaller ascending phase of the sunspot cycle to nearly being at sunspot maximum now. During this time, we got the major increase in UV that is expected during the 11-year cycle. But as many of you know, we haven't had as many Earth-directed CMEs, the particle burst, to decrease the ozone. So of course, without those particles and higher levels of UV, we'd expect 2022 to be a bit better for our ozone layer. Definitely wouldn't give credit to the Montreal Protocol or forget the importance of that layer for when the sun's particle delivery ramps up here in sunspot maximum, or the fact that Earth's weakening magnetic field is going to let in even more of those particles than normal.